All right, so here we're going to be doing 12.2. This is arithmetic sequences. So arithmetic sequences always have this form. It's always going to be A, and then A plus D, A plus 2D, A plus 3D, or the nth. The formula always looks like this. It's A to the n is some A, which I think is the book's notation, which drives me a little bit nutty, right? I was like, should we have it different than what the different indexing? But since I'll use these notes next term and everyone has the book, I'm just going to keep with the nutty notation. Plus n minus 1d. So notice here, at the second one, we only had 1d. At the third term, we had 2d, so it's just n minus 1 of that. So where a is the first term, which I kind of get why they do it, and d is the common difference. So the d is the common difference of the sequence. Find the nth term. The nth term is given by this. Okay, and so here, we're going to just kind of go through, we're going to just kind of mess with it in different ways just to get used to it. So here, if I have A is 2 and D is 3, find the nth term. So the nth term is just 2, we just use the formula, plus n minus 1, 3. Okay, so this is, so if we know the common difference and we know the first term, we can write out any term in the sequence just for fun. The first term, if we were going to just write out a couple terms, the first term would be 2, the second term would be 5, the next term after that would be 8. What's the next term after that? What's our next term? 13's a little high. 11, yeah, 11. Okay, so notice here I'm just adding 3, adding 3, adding 3. And so if you see, and so here, so given the sequence, 9, 4, -1, 6, 11, because this is usually what you'll see, you'll just see a sequence of numbers. If you want to find out if it's an arithmetic sequence, just figure out what's the difference is between each of the numbers. So from here to here, there's a -5 difference. From here to here, it's a -5 difference. From here to here, it's a -5 difference. From here to here, it's a -5 difference. And so D here is probably -5. What's my first term? Well, it's right here, A, or 9. So 9, A equals 9. So I can write out my nth term of my sequence now by saying 9 plus n minus 1 times the -5. Okay, and so notice here, without checking through the formula, if I wanted to figure out what the next term would be, -16, right? The next term would be -21, and just take away 5 each time. Now, if it's given this, do we need to know all this? And so as long as I know it's an arithmetic sequence, I can just take these two, figure out what the difference is, which in this case is, my brain would operate, -6, right? And so here I can find the first 6 terms. So as long as I know it's an arithmetic sequence, I know it's -6. So the first 6 terms would be 13. -6 from 13 is 7. -6 from 7 is 1. -6 from 1 is -5. -6 from -5 would be -11. -6 from -11 is -17. And so notice here we can crunch out the terms, and if I wanted to find the 300th term of this, right, so I just write out my general formula, it would be 13 minus 6 times n minus 1, or n minus 1, hold on, I said minus, did I write it? No, n minus 1. So this is in general, this would be, so the 300th one of this would be 13 minus 6 times 299. And I'm going to crunch that through a calculator. Let's not be super lazy, right? But for the same token, I don't want to crunch that. All right, there we go. Well, from Wolfram alphabet. I need 13 minus 6 times 299. Oops, that is not times. Minus 100, 1781. Perfect. Minus 1781. Okay. All right. So let's tackle something even harder. So let's pretend I know what the 11th term and the 19th term of the sequence is, and I want to find the 100th term. Can you do this? So let me ask you the question. Let me ask the question to the class. Is this possible to do? Not can you do it? Not do you know how to do it, but do you believe it is it possible to do? Yeah. You guys don't seem. Now, why do you believe it's possible? Math. It's math. Anything's possible, right? I wouldn't put it on the paper if I didn't think it was you, because you put it in the notes. I know someone wrote it. Thank you. Fair enough. So here we have the 19th, and we have anything's possible. Duct tape. So let's figure out what we have here. So we have let's figure out what we have here. So we know that 52 is equal to the 11th A11, right? Which is equal to sum A plus sum n minus 1. Well, we know what n minus 1 here. It's 10 times sum d, right? Here we have 92 is equal to a to the 19th, which is equal to sum a plus 18, n minus 1 of 19 to 18, sum d. And now all we have to do is tease out what is what, right? And I don't know if you guys have solved. Our 18 is equal to 52, equal to 92. Have you guys solved simultaneous equations before? Also, as long as you find the answer and get your hopes crushed, it's impossible. Nada. No. So some people have, some people haven't. So in order to do this, you just let's see if I can do this in a way that won't get people confused if you've never seen it before. Solving simultaneous equations is a whole. I teach it. I teach it to my 126 class, and then I reteach it to my 431 class because by that point they've forgotten. All right, so let's kind of tease out how to do this in our head. So if I know 52 is 10 times d plus an a, and I know 92 is 18 times d plus an a, right? So if I took 92 minus 52, I'm left with just 8d, right? Does everyone buy me on that? Because the a's will, if I have a, here, if I took these two numbers, 92 minus 52, which of course is just 40, right? The a's cancel each other out, and I'm just left with 8d. So I know 8d is 40. That's what I know, right? And once I know 8d is 40, I can say d is just 5, right? Because if I took these two numbers and minus them, I'm left with only 8d, right? Because the a's would cancel each other. And 10 of these d's would cancel it, 18 of those d. Yeah, so you just subtract them. In this case, it's just simple as subtracting. And it's always going to be the case for this. You just subtract the two. So I'm left with 8d. So I'm subtracting the bigger one from the smaller one. So I'm left with 8d, that's d equals 5. Once I know d equals 5, I can just use 52 equals a plus 10 times 5. This implies a is 2, right? You're going to see from there, this is 50, so a must be 2. So here I have my formula of a to the n is now 2. You could have done the same here. 18 times 5 would have given you 90. 90, so leave just the 2. So it's 2 plus n minus 1 of 5. So that's my general formula. What am I asking you to find? The 1,000th term. So it'd be 2 plus 5 times 999. So 5 times 999 would be 4990. No, 4995. 4995 plus 2 would be 4997. Okay. So yeah, so if you ever have the 11th term or the 19th term, I think I give you one just to try out. You just write them out into this form. Write out what it's some a plus x amount of d minus the 2. You're going to have x amount of d left equals some number. Then you can solve for d. Once you know what d is, you're just left with a very simple equation. Or right here, I guess the simple equation. 52 plus a, or 52 equals a plus 10 times 5. Well, then you can just solve for a and get that. Okay, so that's how you do that. I'll leave this up for 1 second before I swap. I bust out a calculator at the point. Well, if I have 1,000, so if this is 1,000, right? So it'd be 5,000, and then I just take away 5 of it, it'd be 4,995, and then add the 2. Mental math is a dying art, unless you watch, what's his name? What's his name? Arthur Benjamin. You guys ever seen Arthur Benjamin Fast on a Calculator on YouTube or something where the guy just crunch out numbers like, it's like, man, you guys make me feel bad. Yeah, someone's seen it. Thank you. Yeah, it's not fair. I watch those people. I'm like, I'm just not that smart. Legit not that smart. I mean, my IQ is decently. I did test it at one point just for kicks, right? But compared to the rest of, but I work with math PhDs all my life, right? And so I just look in the room. It's like, you're not the smartest person in that room, not even by a little bit. Gee, there's a massive typo here. It says find this. This needs to be a K. I feel that, not being the smartest person in the room. You know what? You don't have to be the most useful person in the room, or the most valued person in the room. And does it really matter? We all have value, but I don't know. It's not, some people like brag about their intelligence, like, yeah, I'm extra smart. It's like, well, that's great. You were born that way. That's what all the studies show, right? It's like, I have blue eyes, ain't I amazing? It's like, no, that was given to you, right? I don't know. I just don't understand bragging about things that were just handed to you. Maybe that's just me. It's like, if you accomplish something, brag about it, good on you, right? That just means they're insecure. Fair enough. Now, if you're in a romantic relationship, you should compliment people on the many things that are given to them. It makes them feel good. The sign use latex is pretty dope. That's good. I only bragged about my new car to my friends for a week. Fair enough. So yeah, I know it is what it is. So I don't know. Maybe I won't get on my soapboxes. I do all the time, but I'll try not to. Right? So just teach math. All right. So let's do this. Calculate this number. So find the sum of 1, if you add up all the numbers from 1 to 100, right? I don't think so. Where are we at? You have a PhD, so it's nice. That's nice. Did you watch all the Golden Girls? No. Can't say I did. I don't think so. You guys are hilarious. Latex for what? Latex is what I use to program here. feel like if you're really, really smart and you know that you are, you're actually pretty dumb in the grand scheme of things. Yeah. One time latex Ruby. Wow. Wow. Uh, I was talking about, yeah. Never mind. This class took a turn for a worse. Wow. All right, let's get back to math before we get me in trouble. Oh. So here, if I wanted to add up all these numbers, how would I do that? How would I do that? So this is actually a famous story. This is actually a famous story they tell in math about C.F. Gauss, right? Or Gauss. You've heard Gauss all the time. He's like this famous mathematician. And so he was bugging his school teacher because, just wanted to learn so much, and the school teacher didn't have it. Says, well, add up all the numbers between 1 and 100. And he thought about it for like a minute and then pumped out the answer of 5,000 or 5,050. And um, he's like, well, how the crap do you get that? And he's like, well, if I add up all the numbers 1, 2, 3, 4, onward to we'll just do the last couple. Let's say 98, 99, and 100, right? If I add up these two, I get 101, right? If I add up, it's 101. If I add up these two, I get 101. If I add up these two, I get 101. Well, how many am I going to have of those? Well, I'm going to have 50 of them, right? I'll have 50 of them if I run through all of them, right? So I'll have 50. So it'll be 50 times 101, which is 505. So we end up doing the exact same here, right? And so here, if I'm adding up some arithmetic sequence, and here the difference here is 1, right? Here's the difference here is 1, here's the difference here is 1. Oops. Congratulations. 1, difference here is 1, right? So here's my arithmetic sequence is 1. And if adding all up, but this actually works for any arithmetic sequence, right? Any of my arithmetic sequence, if I add them all up, if I add the first two, if I add this one and this one together, I'm going to get 2a plus n minus 1d, right? And then I'm going to have to do half of the number I have, right? Have whatever half number I have of that. Or that's Gauss-Seidel, so I take the first one and the second one, divide it by 2 and multiply by n. These are actually the same. These are legitimately the same. The only difference is in here, they pulled in the 2 and calculated. And so here, if I know a and d, this is easy to use. If I know 2 terms, the first and last terms, this is easier to use. So let's do a couple of these and call it good for the day. All right, so I want to sum the first 40 terms of this arithmetic sequence, right? So here, the difference between these two is 4. The difference between these two is 4. The difference between these two is 4. So what do I know here? I know what a is. A is 3. That's my first term. Okay. And I know what d is. D here is 4, right? I just calculated it. What's the difference between those two? So if I want to know the first two, so a s to the n is so 40 over 2, which is just 20, times 2 times a, which is 3, plus n minus 1, and so 39 in this case, times 4. This you just crunch through a calculator. So it'll be 20 times 6 plus 156. So this ends up being 3,024. I'm cheating for that number. I'm not actually calculating it. Don't let me lie to you. I have it in front of me, right? I pre-calculated this one. Is that 39? Yes, this is 39, sorry. Yeah, because the n would be 40, so this would be 39. Sorry, I didn't make that super clear. All right, so I want you to do the sum of the first odd numbers. So find the first 50 odd numbers. So this would be 1 plus 3 plus 5 plus dot 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 dot, and this actually goes all the way to 97 plus 99. So 99 is the 50th odd number, just in case you're wondering, right? So you can do this either way. You can do this either way you like. And so use either of these two formulas. I'm giving you, you can calculate, here the difference here is 2, of course, my starting number is 1. Or you'll get, or you can use this one, where you take a plus 1 plus this, which gives you 100, you times it, divide that by 2, and then multiply by 50, okay? You guys forgot to divide by 2. Okay, someone got it, yeah, so, heck yeah. So, you just forgot to divide by 2, that's all. So we have 1 plus, so here I know my first and last, so let's just do that one, since I did the other one last time. So we have my first and last, and I divide that by 2, and I multiply by 50. So this is 100 divided by 2, so it'd be 50 times 50, which is 250. Yeah, so, hey, you know what? I'm just happy you guys are out there trying. I legit, just crunching the numbers is helping you get to it. This is, I want you guys to think of this as an art class. There's no such thing as mistakes, there's just learning opportunities. I don't think it's right. I usually don't get things right now. So, you know, I'm really glad that you guys participate. Actually, trying helps you to learn, right? And so one thing to help you to learn is the least amount of pride you have, not pride in the sense of, I'm proud of things I've done, but pride in the sense of like the biblical sense, I guess. It's like, hi, I'm better than everyone. And a lot of times we'll give an answer. It's like, well, if you don't know, see, what's the old axiom? It says, what's the saying? I can't think of it. It's an old saying. It says, it's better to say nothing than to open your mouth and prove to everyone that you really don't know what you're talking about. I'm paraphrasing. There's a more famous way to say it, but if you can get over that and just be kind of messy with math and allow yourself to make mistakes, you're doing great, right? And that way you can test and go and test and go, and it's just part of the learning process. So when you guys type in incorrect answers, I'm zero worried about it. So means you're engaging with the material. All right, so let's do this very last one. So how many terms of this arithmetic sequence must be added to get 572? So in order to do this, we have to think backwards, right? And so let's just think backwards for a second. So I know what the answer is. I want it to be 572. Here, I don't know what my last term is because I want to know how many terms I have altogether. So I'm going to have to use this formula right here. So I'm going to use this formula right here. And so it's going to be sum n, which I don't know, divided by 2 times 2a. Do I know what a is? Yeah, a is 5, right? So 2 times 5 times 5 plus sum n, which I still don't know what it is, times, well, what's the difference here? 2, 2. So the difference here is 2. Okay. All right. So now what we're going to do? Well, in order to solve this, I'm just going to multiply my n in. So I'll have 52. If I chuck the n over 2 in, so it'll be the 2's cancel, so I have 5n. So my first term is 5n plus, what do I have here? I'll have n times n minus 1, and then the 2's will cancel. N times n minus 1 gives me n squared minus n. So that ends up, so it'll be n squared minus n. So minus n plus 5n would be plus 4n is equal to 5272. But what we'd actually do from there is we'd put n squared plus 4n is plus 572 equal to 0. And at this point, chunk it through a calculator. It is possible to factor it. This is n22 and n plus 26, right? Is equal to 0. That means n is either 22 or negative 26. Well, negative 26 doesn't make any sense, right? Because we can't add up negative terms.